Imagine you're drifting above the Earth. There is only blackness, silence, and the endless vacuum of space. Now picture squeezing the trigger of a cannon. What happens next? There is no air to carry the sound, but the laws of physics are very much alive. When you fire a gun in space, Newton's third law takes over. Every action has an equal and opposite reaction. The bullet shoots one way, and you, or your space station, are shoved the other. It sounds like science fiction guns blazing in orbit, the recoil sending astronauts tumbling into darkness, but this is not imagination. In 1974, the Soviet Union did the unthinkable. They built a cannon, sent it into space, and fired it while orbiting the Earth. It was a test cloaked in secrecy, a chapter of space history hidden for decades. Why would anyone put a weapon on a space station? The answer lies in fear, rivalry, and a desperate race for supremacy between two superpowers. As the stars watched in silence, humanity's first space cannon made history. Quietly, violently, and alone. That single event changed the course of military space technology forever. The echoes can still be felt today as nations look to the heavens and wonder, what else is out there, waiting in the dark? The 1960s and 70s were an era of high stakes and higher tension. The United States and the Soviet Union competed in nearly every arena: sports, science, and especially space. But beyond the public's gaze, the rivalry was not just about planting flags or collecting moon rocks. It was about who could dominate the ultimate high ground. America's ambitions in orbit were not always peaceful. The U.S. Air Force had its own top-secret projects like the Manned Orbiting Laboratory, designed to put soldiers, not scientists, into space. Their missions, surveillance, reconnaissance, and possibly more. Documents only declassified decades later revealed plans for cameras so powerful they could read license plates from orbit. Some even whispered about weapons, lasers, missiles, and guns meant to defend these platforms from enemy attack. Such rumors did not escape Soviet ears. Intelligence leaks, spy satellites, and propaganda painted a picture of American space stations bristling with arms. The Soviets understood what was at stake. Whoever controlled space could control the world below. So the race was on. The Soviets would not be left behind. If the Americans were arming their space stations, the USSR would answer and escalate. Thus, the seeds of an orbital arms race were sown in secrecy, paranoia, and a relentless drive for military advantage. A response was necessary, and swift. The Soviet Union launched Project Almaz, a covert military program designed to match and surpass anything America could place in orbit. Almaz means diamond in Russian. But this was no glittering jewel, it was a fortress in the sky. Project Almaz had one goal: gather intelligence and defend itself against any threat, real or imagined. The Soviets envisioned a fleet of armed stations orbiting the planet, eyes and weapons pointed downward and outward. The project was hidden behind the civilian Salyut program, which the world knew as a series of peaceful research outposts. In truth, some Salyut stations were military through and through. The architects of Almaz wanted more than cameras. They wanted to test what was possible: military hardware, new technologies, and, most astonishingly, weapons in orbit. Almaz stations would use powerful telescopes to spy on American bases, ships, and even aircraft carriers. But spying alone was not enough. The Soviets needed a way to defend their precious asset from attack. Secret meetings, high-level directives, and the best engineers in the USSR came together to turn this vision into reality. Project Almaz was a gamble, but it was a gamble the Soviets felt they had to take. The stakes were nothing less than the balance of power in the Cold War. The crown jewel of Project Almaz was Salyut 3. Launched in June 1974, it looked like any other space station from the outside: a cylindrical shell, solar panels, and a docking port for cosmonauts. But inside, it was a fortress. Salyut 3 was equipped with state-of-the-art cameras and sensors. Its mission was clear, observe, photograph, and report on American military activity. The crew, hand-picked Soviet Air Force officers, trained not just for survival in space, but for reconnaissance and military operations. Every move was watched by mission controllers back in Moscow. The station's thick armor protected it from micrometeoroids and, possibly, enemy attack. If American astronauts tried to board or destroy Salyut 3, the crew was prepared to respond. Hidden in the shadows of the station was its most secret asset, the R-23M cannon. Salyut 3's mission lasted just 7 months. But in that time, it captured thousands of images, and proved that an armed outpost in space was possible. The world saw only the smiling faces of cosmonauts. The truth was far more dramatic and dangerous. The R-23M cannon was unlike any weapon ever built. It actually started life as an aircraft autocannon, designed for Soviet bombers. But then, engineers at OKB-16, led by Alexander Noodleman, reimagined it for space. The result was, well, chilling. A 23mm rapid-firing gun, fixed along the station's long axis. Why a fixed gun? In space, every force has a consequence. If the cannon could swivel, the recoil might send the station spinning wildly out of control, so instead the R-23M was locked in place. To aim, cosmonauts actually rotated the entire station, using thrusters, so the cannon would point at its target. But firing a gun in space is no simple matter. The station's mass helped absorb some of the recoil, but each shot still nudged Salyut 3 in the opposite direction. Engineers had to calculate precisely how many rounds could be fired before the station's orbit or attitude was compromised. The cannon fired special vacuum-rated shells, and each round shot out of the barrel at over 700 meters per second. The purpose? Deterrence. If an enemy spacecraft approached, Salyut 3 could defend itself. In reality, though, it was a symbol of fear, a weapon built not for use but for warning. Yet the Soviets would not settle for theory. The cannon had to be tested. January 24, 1975. Salyut 3 drifted over the night side of Earth. The cosmonauts had already returned home. Ground controllers prepared for a test that had never been attempted before, firing a gun in orbit. The station's thrusters roared to life, rotating the entire structure so the R-23M aimed safely away from Earth. The target? Empty space. No crew on board. Safety systems double-checked. Then, a command from Moscow: fire. The cannon spat out bursts. Reports say between 1 and 3 full rounds, and some even claim up to 20 shots. In the vacuum, there was no sound. Only the recoil jostled the massive station, swinging it slightly off axis. Sensors recorded the results. Cameras watched the shells disappear into the void. The test was a success. The station survived. The cannon worked. But what did it prove? For the Soviet military, it was reassurance. For the world, it was a secret, one that would remain hidden for decades. The Soviet Union specialized in secrecy. News of the space cannon test was classified at the highest levels. Only a handful of officials and engineers knew the truth. The cosmonauts themselves spoke little, sworn to silence by threats and loyalty. Official reports described Salyut 3 as a peaceful research mission. The station's crew returned as heroes. There were no hints of weapons, no leaks to the press. Western intelligence agencies suspected something, but without evidence their suspicions remained just that. Years turned into decades. When the USSR collapsed in 1991, archives began to open. Only then did the world learn of the cannon in orbit, the test, the technology, the risks. Historians pieced together the story from declassified documents, interviews, and fading memories. The space cannon became legend. But for nearly 20 years it was just another secret lost in the swirling dark of the Cold War, a reminder of how much we still don't know about our own history in space. The Soviets had bigger plans. The next Almaz station, OPS-4, was to be even more formidable. Equipped not just with a cannon but with guided missiles. The dream was an armada of armed outposts ready to fight for supremacy in orbit. But history intervened. Technical problems, budget cuts, and changing politics doomed OPS-4. The Almaz program was cancelled. The USSR shifted focus to civilian science and cooperation with the West. The world would never see a battle between armed space stations, at least not yet. Still, the echoes of Salyut 3's cannon test lingered. The idea of weapons in space did not die. Instead, it evolved. Modern anti-satellite missiles, laser dazzlers, and cyber attacks are the new tools of orbital war. Nations still watch each other from above, and the race for dominance continues. The ghost of the space cannon haunts every new treaty and every test. The lesson of Almaz is clear. The line between science and war in space is thin and easily crossed. Today, the world faces a familiar dilemma. Satellites control our communications, our navigation, even our economies. The temptation to arm them, to defend them, is stronger than ever. But every weapon in space risks a new arms race, a spiral of secrecy, suspicion, and escalation. In recent years, the United States, Russia, China, and India have all tested anti-satellite weapons. Each test creates debris, endangering every spacecraft, every astronaut. The darkness above is crowded, fragile, and easy to shatter. The story of Salyut 3's space cannon is a warning. Secrecy breeds fear, fear breeds arms races, and no one wins a war in orbit, not the attackers, not the defenders, not the people below. The future of space should be open, peaceful, and shared. So we must ask ourselves, will history repeat, or will we learn from the silent shot fired in 1975? The stars watch us still, waiting for our answer.